Hello everyone, welcome back to the channel. In today's video, we're going to be attempting to decode event logs from a contract that is not verified. So we're going to decode this particular contract, and if we click onto this contract, I don't think the ABI is there. Yep. So but this transaction is transaction in Kaya, the blockchain, and yeah, let's get right into it. So the only thing I know from here is that it is an NFT sale, and we do see that, we can get a few things from here. One is that this particular address interacted with this 608 address, and if you go to event logs, the only useful information is that we know the 608 address is the NFT, at least the NFT platform address, and it has this orders matched event, which is very similar to CPOT 1.6. CPOT 1.6 also has an order match, but if we look at the topics, I don't think they match. So yeah, let's look at an overview. The other thing that we have is we know the NFT transfer direction. So we know that it's going from this FBC address to the 331 address, which is the one who initiated the transaction, which means this is the buyer of the NFT, right? And they received this NFT address, and this is the token ID. So they paid this amount, and then they paid this amount to buy the NFT worth this one. The things we don't know here are, I guess, the platform fees, if any, or royalty fees, if any. That might be hard to decode, but we are trying to make a generalized query to get most of the NFT transfers that are going through this contract. Okay, so there are a few things that we can do when it comes to unverified contracts. One is we can check topics if it exists in other chain, and then check function calls if exists in other chains. So what I mean by the first one is if we click on event logs and try to find which is the event that has that makes most sense to decode, I am drawn to this orders match, and in the orders match, when it's decoded it's an array of bytes 32. Excuse me. And this bytes 32 there's two hashes, right? B1C9. And if I just search B1C9 in this same transaction, I get several hits, right? I get this. But this two is not really useful because the data field is null. This is 0x, so not useful. But this particular topic does have B1C in its first 32 bytes in the data field. So this topic will be useful, and so this is my first clue. Topic, right? And the other hash being this hash, I'm going to copy this and paste it. And I see the exact same thing happening here, where again this is the same topic, right? And it appears in the first 32 bytes of data. So what this tells me is that these two topics, these two event indexes with the same topic could be something like this might be the sell order, and this is the buy order, right? Maybe this is the listing, and then this is the buying sale, and then when there is a listing and a sale order, then they match, and they are able to match via this orders match. Okay, so these are the two important topics. The other thing to know is also we can just copy the buyer address, let's say this one, and try to search the address, and we get one hit, which is here. Let's remove the 0x and see if we get another hit. And we do, we get it here. So it appears in topic 1 for this event, and at the end of here. So that's interesting. Okay, so I feel like we can start to query the data and see what we get. So select from hire.core.fact event logs. See 2025 January 5. Oh, wait, what timestamp is this? GMT 9. This is and then the topics that we're interested in, there are two, right? One is this one, is the sale related one, and then the other topic being the bytes matched, orders matched. Okay. That would be this one over here. Then we just want the x topic 0. But data. I guess we need topics 1 as well, right? Topics 1. What I'm missing here is the excuse me, the function to sort of cut data into chunks of 64 characters. So I don't have that saved up. I just look it up each time. There you go. And remove this. Okay. So let's call this as like segment. So I have some sort of sale event and sort of order match event, and the order match lists some sort of hash, right? The two hashes, and through this order match we're able to join the two hashes together. So we're not that worried about the match because we can, sort of like write a query to decode the two hashes and then flatten it and then join again. I think we're just concerned about the sale event and being able to know how to decode this, or at least like a generalized query, right? Okay, the next thing I want to try is, are there other topics in other chains? So this, if it exists in other chains, then it might be useful to help us to decode it better. So I'm going to copy this and look for it in Ethereum. So say something like select from Ethereum fact event logs, right? Make this as 2024. X hash event index and topics 0. Okay. Let's run that query and see if we get anything. In the meantime, we can start to do two things. One is we can copy the NFT address. So let's just copy this and say NFT address is. You can copy the token ID 3135, convert it to hex. So into hex. And the reason why we are converting into hex because in the data field it will be hex value, and so after converting the hex value to integer, it will be token ID, and so we just need to do it the other way around to get the hex. So 3135, and we get C3. So token ID is C3F, and it looks like we did not find any in Ethereum. Let's look at base. If we do not find any in base, I think we can just move on and try to decode it ourselves. So that's topics running. Function calls. What is function call? I'm looking at the internal transactions or traces, and this is the exact one that I want to see, where it says this is the person who initiated the transaction. They interact with the contract, and it's just a call, which means this contract itself is or has all the logic, right? It doesn't rely on an implementation contract, and the function signature is this. So I might just search this in Ethereum and see if I get any hits. One 691 691 plus 019. Okay. Oh, okay. Oh wow, okay. So it looks like so if you guys remember earlier, this is the seller address, which means the NFT seller, and they receive only 1.691, even though the buyer transferred 1.9, which means there are some fees, right? And the fees goes to a few people. One of it goes to this address. Could be the platform fees, could be yeah, I don't know whose address is this. It's a contract, so I'm guessing it's a platform fee. And it also goes to this address and this address, which could be the royalty recipient for this NFT. So very interesting. Let's see if it ran. Okay, so no results for topics, so no hits. It's more than likely we won't get any hits for the function calls either as well. So we're gonna have to decode this manually. The other thing I'm hopeful is that we have all these values here, which means we can convert these values into hex and then see if it matches in our event logs. So total sale value 1.9, so this would be like 1.9 would be 10 half 18, I think. Man. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Oh, this should be in. Okay, do we have this amount somewhere? Okay, we do. Interesting. Okay. Then I'm gonna write 0.019, so means 1, 2, delete 2. We have this amount. We do, but it's in the longer event. Okay, so uh, then do we have this amount? Usually royalty fees, it will be like it'll be represented in percentage. So I don't know if we can get the flat amount. Like this is this is this value is divided by 100, so it's 1% of 1.9, and 1% means it is 100 bips. No, wait, 1,000, 100, 1,000 bips. Let's see, 1,000 bips is 1%. Oh no, 100 bips is 1%. Okay. So in that case, need to find 100 before. That's not very useful. Just search for it. Come after a bunch of zeros, and I don't see it here. Okay, so it's not represented in bips, at least for the platform fees. Let's try 0.076 plus 0.14. This is 0.19, which is 10% royalty fees, and 10% would be just a. Oh man, it's gonna be hard. Yep. Okay. So royalty is not represented here, which is a shame. Fine. So I think we can go back to our query over here and sort of see what we have. These topics. Okay, so these two are the sale events, and this is the bytes match. Sorry, order match. And so we are looking for buyer is the buyer is 331 and seller is so right off the bat we see that the first event is the seller, right? See how this matches to the seller. The second event is the buyer, and the second event is also shorter. Always good. So I'll copy this into a JSON viewer. Oops. Okay, next we can start to search some stuff. So in this place, does the buyer exist? The sale value. It does, and it does in the 7th row. Platform fees. All right. Okay, so how do I extract this value? So this first two yells it's an offset, right? 60 is I need to hex in this. It's 96. 96 divided by 32 is 3. So skip the first 3 is 1, 2, 3. and this first line tells us 1. I don't know what this 1 means. It could be like 1 NFT, and then the rest is the parameters. So let's just note that down somehow. Maybe I'll note it down here. So buyer topic, where is it? I'll just say like array 1. Array 1 tells me there is array 3, line 3. Line 3 tells me there is 1. One sale, maybe? And then rest of line represents sale perhaps. The second one is 100, so let's convert 100 to, oops, what did I copy? 100 to decimals, and 256 divided by 32 is 8. And so 8 would be 1, 2, 3, 4, 5, 6, 7, 8. So skip the 8 lines, and then we go to the next one, which is line 8. So line 8 tells me there is 1. So because the offsets end here, this means line 4 to 7 represents the sale events. Okay. So line 4 to 7 represents sale params, right? So what can we get from the sale params? The first thing is null. So there's like 3 nulls here. So we don't exactly know what these nulls represent. It could be like Boolean, right? But what exactly is the Boolean, we don't know. And then this one here represents the sale amount. The sale amount is this one over here. So we know this is the amount that the buyer needs to pay. And then let's note that down, right? Line 7, amount that buyer needs to pay. And then line 8 tells us there's 1. And then line 9 to line 13 should be I don't know what's this, but let's look at other stuff we have, right? We have NFT address. Oops. Okay, so NFT address appears on line 10, and line 10 is like the next part of the offset. Write it down. That's 1 of something, right? And then line 9 to 13 represents that something, right? And because we see that line 10 is the NFT address, let's look for the token ID, C3F. There you go. So NFT address and token ID is together. So that tells me line 8 is, so line 3 would be like the sale amount. And line 8 is the tokens, NFT tokens transfer. It's NFT, right? So NFT related information. So line 9 to 13 would be NFT related information, right? And we know line 10 is the NFT address. Line 10 is NFT address. Line 11 is token ID. And usually after token ID is followed by quantity. So like how many of the token is transferred. So I'm just gonna guess it's quantity here. And then I have this C331, which isn't this the buyer? Yeah, it is the buyer. So the last thing in the data is the buyer. Kind of redundant because it's already in topics 1. Okay, we don't know what this 2 here means. Are there any clue here? I mean, 2 converted to decimal is still 2. 2, what is 2? 1.9, where's my 0.9 minus 1.61, we get 209. Divided by what am I doing? 9 what? 1.9 minus 1.5. It's 11% goes to the seller. I mean 11% taken out as fees. 1% 1% platform fees and 10% royalty. So the 2 here doesn't really help. I think that's fine. So from here, we already know several things. We know that we can use the buyer side of the topic, to be able to derive the sale amount, to be able to derive the NFT address, token ID, and also how many, and who is the buyer, I guess. Now, I guess we can already write the logic for this, but it would be good if we can verify several things. For example, what about one is multiple NFTs, two is payment not in Kaya, right? The native token. Which reminds me, I think this, remember there's a bunch of zeros here? One of these zeros could be the token address, because for native tokens, whenever they appear in event logs, they are represented as a bunch of zeros. So this here could be token address, right? Maybe. So we're looking for some examples where it is not Kaya. And let's see how we can do that. The way you do that is I would find an order match event and join it with token transfers and see if there are token transfers. So what am I doing? Let's first find for multiple NFTs, right? So I want my event here. So with sales as, and then uncomment all this, and I just want the order match event. Let's say after January 1st, px hash, right? And then my NFT sales, NFT transfers is, do I have NFT transfers table? Oh damn, I might not have an NFT transfers table in Kaya. Oops. Oopsie. Yep, I do not. That's a hassle. Let's see. How can we hack this? NFT transfers is, I guess we just have to do an event logs. Oops. Oh, there you go. No wonder it's not. Man. Okay. Let's just use this as an example first. From the transfer, and then data is not down, and then I think that's it, right? see if this is sufficient for an FD transfer filter. Okay, it is. That's 390. 390 is open. Okay. Verify this. So this is a token transfer, and event logs would be there is a value. From to. Oh no, okay, so transfer events all appear in topics, right? And then token ID is in the data field. Top NFTs, cannot. This. Yeah, see, this is what I meant by how it's similar to Seaport, because it does have the orders match thing. Just that the topics doesn't match, so that means they change something. They change the event name, and they change or either event name, or they change the type. Probably event name, now that I think. So probably can just use this. Transfer. This is token. So okay, so topics 3 is the token ID and data is 0x. Okay, got it. So why? So it should be topics 3 is not now then. And then what's in data? The data is 0x and data is topics 3 is not now. Let's do that. 0, 1, 2, 3, and this is token ID. Okay, cool. So we have entity transfers. We're gonna comment this out and say x hash count1 group by 1 having this one select from transfers sales Okay, so what am I doing here? I am creating an entity transfers table, just 7 to 1, and I'm looking for transactions where there are multiple NFTs sent in a single transaction that also has the sale event. For this one, I forgot to specify contract address. The contract address would be yeah, let's run it again. Which also reminds me we need to have a contract address up top. So where is that query? Right here, right? And the contract address. Okay. All right. We have some results. So let's take a look at this result. 2 weeks ago, this person interacted with this address, paid this amount in Kaya, and what's that too? Oh, okay. So there are two NFTs, right, being transferred. Yeah, this looks good. So look at event logs. We're looking for where the topic 1 is the buyer. So A667, fine, for topic 1 is the buyer, and this is the topic. Topic 0 is this. Okay, this is correct. Yeah, cool. Let's have this as our another example. copy that query, comment out all this, and comment back. I believe is this. X hash in. You can do something like this. Call this as like 1 sale, 2 sales. I don't know if they support other token addresses, but yeah. So let's just run this. Okay, I need the X hash here, and probably don't need the orders match now. So commenting that out, and I guess what's important here is what's important here is that topic where it is the buyer, right? So topic 1 should be the buyer, and the buyer for this transaction is the buyer is A667. So buyer is A667, this, and the buyer for the first transaction is C33. So this is is these 2 events that we want to look at. Interesting that the second transaction has 3 topics. I mean 3 separate events. Maybe because there are 2 NFTs, right? So how does the order match look like? Oh, so it's 1, 2, 3, 4. Wow. Sorry, 3. So 1, 2, 3, right? Yeah. Interesting. Okay. Interesting. Yeah. Okay. So let's sort of add that filter in here, which is not the right filter, but I want to add this in just because it's easier for me to work with. Topic 1 is the 2 things that we saw. So it's this one. So this would be the this is the buyer in first transaction. This is the buyer. So obviously not a good filter to use in your final query, but for the purpose of being able to decode the data, this is what we have. Okay, and let's look at the data portion for the second transaction. This one, the first line. Okay, immediately I see that it's now longer than the first one. And so let's confirm our hypothesis, which is, line, the first 2 lines is the offset, right? Here, yeah, that looks like offsets. And line 1 to 7, sorry, 3 to 7 represents the sale amount. So line 3 is the first offset, so until 7, yeah, that looks right. And then line 8, previously line 8 is 1, which would mean like 1 NFT, but now line 8 has 2, which means there are 2 NFTs. And yeah, we see this 02, which we don't know what this means, right? We see it in here as well, 02. I have a feeling it's like it's the position, like you skip 2, 1, 2, maybe, right? Still not sure what this is, but this is the NFT address. This is the token ID, and this is the quantity. And this would be the buyer, and you have the same thing, 02, NFT address, token ID, quantity, and then buyer. Perfect. So that itself, that alone itself tells us everything we need to know, which is the sale amount will appear in only one sort of like one section of offset, and then the NFTs so if there's more than one, it will tell you the number of NFTs here. So two. So this one segment is one, and the later segment is another. Okay, so we have everything we need. Let's try to write that query. Let's see. All this is raw. And what is it? All this is like finding examples with more than one NFT, right? I push this way lower down. And this one would be our raw table. And first up, we need the sale amounts. So sale amount raw as select from raw. How we know the sale amount raw is because we just need the second segment. So segment 1. Segment 1 is what? Segment 1 is, I mean, you can do it the easy way. The easy way is just to assume that all segment 1 is the same because the length of the payment is the same. It will not change. So we can just take the line 7 right away. That's definitely an easy way, and I don't mind just doing that right now. So segment 7 is the sale amount as total sale amount, and maybe segment 6 is the token address, right? I don't know. I'm just gonna leave a comment here, right? Segment 6 might be token address. And the way to find this out is you do this same query below, where instead of looking at NFT transfers, you look at token transfers and see what are the examples of tokens transfers being transferred, right? And that segment 6 can be your token address. But for this purpose, I'm going to assume segment 6 is the token address and leave it empty for now. And then of course, utils convert this from hex to int of segment 7, and this gives me my total sale amount. So let's just double check that, right? I'm expecting this to show me 2.4. Oh, sorry, like 24 and then a bunch of zeros, and then this one will be 19. So let's see. Right, 24 and then 19. Okay, let's move to the next part while we wait for this to run. Next up is my NFT information, right? So let's call it NFT segment, right? From raw. Okay, so 2419, which is what we expected, so that's fine. You can just remove this. NFT segment would be it consistently starts off at segment 8. Yeah, segment 8. So we can just say segment 8, and then of course do this same hex to int as NFT count. And so if the NFT count is like how do you, so because you know the NFT count, how are you able to dynamically get the NFT stuff, right? The way that we do that is because we know the number of lines for each NFT segment, right? So in this case, 9 to 13 is 5, and if we see here, 9 to 13 is 5, and 14 to 18 is 5. So the next 5 lines represents each segment. So we can say something like So we know the segment is of length 5, and because we know it's 1, we can take the count, multiply by the length. So something like NFT count times 5, and 5 here is because number of rows is 5. And so NFT count times 5 would be 5. And we start off with 9. So it should be NFT count plus 1 plus whatever this is. Let's see if that makes sense, right? So NFT count is 1. So not plus 1, plus count is 8, right? So it should be 8 plus 8, right? So segment 1 plus 8 is 9, 9 plus 5 is 14, and this is wrong. So that means we just remove, we just count this as like 7. Now NFT count is 1. No, this should be minus 1. Something like this. Right. So NFT count plus 8 is 9. And plus NFT count is 5, so it's 5. So 9 to 14. 14 minus 1 is 13. Yeah, I think that's right. Let's verify this for the next one as well, right? So NFT count is 2. So NFT count is 2, that means it's 10, which is not right. So this should be a fixed number. This should just be 9. Wait, should it be 9? It should be 9 to 18. Write it down, right? 9 to 18, and the first one is 9 to 13. And we're trying to come up with a way to get 9 to 13 and 9 to 18 based on the NFT count. So let's try to work this out. NFT count is 1 times 2. So it starts off at segment 9. So maybe we just hard code 9 here. So something like 9 plus NFT count is 5. This would result to 1 times 5, 13. Okay. And then if it is 2, 2 is 10, 19. Oh, I think this works out. So 2 times 5 is 10. 9 plus 10 is 19. 19 minus 1 is 18. So we get 9 to 18. Yeah, this works out. So I'll just make it 8 because 9 minus 1 is 8. Yeah, I think that works out. Okay. Let's see. Yeah, okay. So I think the issue now is how do we filter for when the NFT segment is between this and this, right? I'm sure there's an easy way, but I'm blanking out right now. I'm just gonna join it. So call this as like count, and then call the segment as from raw. Let's join NFT count using and then I will say where segment. No, wait. I need a segment, but I need to row number it. How do I do that? I've done this before, but I don't remember. Segment between I need to do like something like, where index is between 8 to 8 and this number, right? Whole number. But to do this, I first need an index of all the arrays. So that means I just need to add a row number here. I need to flatten. Okay, I'm just gonna try it out. Raw flatten segment. See what I get. Like this. The table. Okay. Yeah. Okay. Okay, I think that's what I need, right? I need the index, I need the value, and first I need the transaction. So FDS. I'm flattening all of the value here, and I want to join with inner NFT count using here. And I want to say my filter would be where index between 9 and then this thing. Yeah, I think that makes sense, right? Invalid. Oh, okay. Valid identifier. Because of the weird way I'm joining. Okay, fine. Let's take it out then. Select all from flatten NFT. Join. So like this. Hash. Raw is TX hash. Oh. Okay, so now I should be getting for the first transaction I should get 5 rows, and for the second transaction I should get 10 rows because 5. So 15 rows. Okay, that's a good sign. We'll just sort this by ascending order by transaction. So this is my first transaction where there are 5 rows. And yeah, I guess this is the way to do it, right? Because we now have index of 9 to 13, which is what we want. 9 to 13. And then this one will be 9 to 13 and 14 to 18. So 9 to 13 and 14 to 18. Okay, awesome. We made it. So now it's the problem of figuring out where is, what is what. And the way I would do that is first number this. So call it as like tx hash. And then row number over partition by, or do I do C? No, I think row number first. So row number ordered by x hash ordered by index ascending as intra index, why not? And the value, of course. So by doing a row number, I am, oh wait, I should be doing the row number after this join. Okay, so let me just get it out then. So the segment raw and text. Select from hash value. Yes. So now the reason I'm doing this is because now each transaction will be numbered 1 to 5. Yeah, so no, 1 to 5, and then 1 to 5, and then 6 to 10. And I can sort of change this number to a specific number in groups of 5. And the way I would do that is I would say ceiling. I forgot the notation for this, but I think it's this, right? Let's look it up. Ceiling snowflake. Input scale. Yeah, I think that's correct. As grouping. Oops, what does this mean? Unexpected value. Oh, my bad. So we're just dividing the numbers by 5. So for example, 1, 2, 3, 4, 5. 1 divided by 5 would be 1. Oops, something isn't right here. How do I use this? So just divide by 5. Oh yeah, okay, my bad. It's there you go. Let's see, this grouping is it? Oh wait, it is right. Okay. So essentially what I'm doing is I wanna be, because it comes in chunks of 5, I wanna be grouping like this together. This first 5 and this second 5 and the last 5 together. And so how to do that is you just divide by the number of things in the group. So divide by 5. And 1 divided by 5 will be 0. 0.2. But because we apply the ceiling function, it rounds it up to the highest integer, and it should be 1. And yeah. And let's say for this one where there's 10, 6 divided by 5 is 1.2, and 1.2 rounded up to the nearest integer is 2. So that's how we sort of group these two together. And now finally we can after grouping this up, we can now convert them back into an array. Oh my god, getting long, but we're close. So I'm just call this as like and then select from this x hash grouping, then array. What's the command again? within group order by, okay. Within group order by interest. Does this do the trick? Let's not a valid group by within why? Because I need a group by. Array aggregate value within group followed by index. Do I need a group by? Oh, okay, cool. That works. Yes. So now we have three things because this transaction has only one segment, and the other transaction has two NFTs. So that's why there's two. And now, finally, we'll be able to use the array to grab the things we want. Like for example, segment 0 is whatever, but segment 1 is the NFT address, and segment 2 is the token ID. And we can do that for both at the same time. So I'm just gonna call this as NFT segment, and then select from NFT segment something like NFT array 1. This would be NFT address. So NFT address is applied the classic 2540. Address. And then the next one would be 012. So 2 would be the token ID. ID. Am I doing anything right? And then I'll do the quantity, right? Why not? To be quantity. Okay. Perfect. And then we can finally join it back to our sale amount. Right? Inner join sale amount using transaction hash. And maybe not join it back because the sale amount will be duplicated, which would be tricky. Yeah, maybe it needs to be like divided into 2 or something, right? Because it doesn't tell you how much of this goes to one over the other. I guess it does in here. Oh, I see. Okay, so it seems like the sale amount needs to be derived from the seller and not from the buyer topic. It's bad because we've done everything from the buyer. But I think that's fine, right? Like, I'm just gonna run this query and call it a day because I feel like that should be enough. Should be enough of me yapping to show you how to get the NFT address and token ID. But yeah, that's how you extract NFT address, token ID from dynamic from data that has potentially more than one NFT addresses, right? How do you dynamically extract data here and data here, right? This is exactly how you do it. We have to, first we have to flatten the segment to be able to get the index, and then do this filter for the index, and then apply this, divide by 5 ceiling to make into groups of 5, and finally array aggregate to put everything in an array based on their group, so that we can do very simple conversions like this. Yeah, I think that's it. If I had more time, I think I would decode the seller portion as well, because the seller portion would contain um the listing price or the sale price, so that you can get the sale price for the individual NFT addresses. Because if you get it from the buyer side, you only get the total sale amount, right? Not the individual sale amounts. All right. I don't know what your takeaways are from this, but I hope you had fun going through this. Yeah, thank you so much for watching, and I'll see you in the next one. Bye.